Here we have to integrate 2x plus sine 2x upon 1 plus cos 2x. Here 2x will be as it is. Let's try to simplify our denominator. We have 1 plus cos 2x, which can be rewrite as 2 cos square x. So to maintain the same angle, we have to simplify sine 2x also. It can be simplified as 2 sin x cos x. For further simplification, let's give individual denominator. So in first term, we will get x upon cos square x, or we can say x into sec square x. And in second term, 1 power of cos will cancel out. We will get sine by cos, which will convert it into tan x dot dx. In first integration, we have algebraic term into trigonometric term. If we go from the left hand side, algebra come first and trigonometry will be later on. So your x will be considered as u and sec square x will be v. So let's try to apply the formula. In first term, your x will be as it is. We have to integrate sec square x, which is tan x. Then minus integration of differentiation of u, which will be 1, and integration of sec square x, which is tan x dot dx, plus your second term will be remain as it is. So as you can see, we have minus integration of tan x and plus integration of tan x, which will be cancelled out. So your final answer will be x tan x plus c. Tada! Which is given in option C. Here, your in is integration of x raised to n into e raised to cx, where n is greater than or equal to 1. And we have to find out c into in plus n into in minus 1. So, first of all, let's try to simplify our in, which is integration of x raised to n and e raised to cx, which is product of algebraic term and exponential. So x raised to n will be u and e raised to cx will be your v. So let's apply integration by parts. In first term, your u will be as it is. You have to integrate your v e raised to cx dot dx. So its integration will be e raised to cx upon c. Coefficient of x divide karano bhulwan nahi. Minus integration of product of differentiation of your u, which is x raised to n. So it will be n into x raised to n minus 1. And integration of e raised to cx, which is e raised to by c. Here, your first term will be remain as it is. In second term, we have two constants n and c. So let's take them outside. And we have integration of x raised to n minus 1 into e raised to cx dot dx, right? Which is nothing but your I of n minus 1. To get I of n minus 1, just we have to replace n by n minus 1. So here we'll get x raised to n minus 1 and e raised to cx dot dx. So your in must be x raised to n into e raised to cx by c minus n by c into I of n minus 1. Now just rearrange the term. C will be go on the left side. We will get c into in, and this minus n into in minus 1 go on the left side will become plus n into in. So on right hand side we will get x raised to n e raised to, which is given in option A. Ta-da! Here we have to integrate sine log x plus cos log. Here your inner function is log x. So let's assume log x is equal to t. So you will get x is equal to e raised to t. differentiate both the side, we will get dx is equal to e raised to t dot dt. So let's modify our integration. We will get sin t plus cos t, and your dx is nothing but e raised to t dot dt. Now, as you can see, we have e raised to t within the multiplication of dt. So we have to apply e raised to x fx plus f dash x formula. If we select sin t as your function, then we will get its differentiation within the summation of ft. So to integrate this term, we just have to neglect the f dash t, and your answer will be sin t into e raised to t plus c. And to get the final answer, just substitute the value of t. Your sin t will be sin log x, and your e raised to t will be x plus c, which is given in option D. Ta-da! Here we have to integrate log x upon x cube, or we can say we have integration of x raised to minus 3 into log x. Here x raised to minus 3 is your algebraic term and log x is your logarithmic term. So we will select log x as u and x raised to minus 3 as v. So let's apply the formula. In first term, your u will be as it is. We have to integrate your v, which is x raised to minus 3. So its integration will be x raised to minus 2 upon minus 2 minus integration of differentiation of u, which is log x. So it will be 1 by x, and integration of x raised to minus 3, which will be x raised to minus 2 upon minus 2 dot dx. So let's rearrange the term. We will get log x upon minus 2x square, and here minus 2 will be take outside, so we'll get plus 1 by 2, and we have to integrate x raised to minus 3. So here your first term will be as it is, plus 1 by 2, integration of x raised to minus 3 will be x raised to minus 2 upon minus 2 plus c. Or for more simplification, we will get minus 1 upon 4x square to log x plus 1 plus c, which is given in option B. Ta-da! Here we have to integrate 1 upon log e base x, or we can say, if we apply the property of log, we will get log x base e. And we know that to integrate log x, we have to take 1 as a v, and log x will be selected as u. So let's apply integration by parts. In first term, your u, or we can say log x, will be as it is, and we have to integrate v, which is 1. So it will be x minus integration of differentiation of u, or we can say differentiation of log x will be 1 by x, and integration of v, so it will be x dot dx. So here x will cancel out, your x log x will be as it is, and integration of 1 will be x plus c. Option માં તો આવું કઈ છે જ નહીં. So for simplification, we can take x common, so we will get log x minus 1 plus c. To get the answer within the option, we have to take log e instead of 1. So here we'll get log a minus log b, which can be rewritten as log of a by b plus c, which is given in option C. Ta-da! In this question, we have integration of x e raised to 2x is equal to this e raised to 2x plus fx, and we have to find the value of fx. So for that, let's find out integration of x into e raised to 2x. Your x is algebraic term and e raised to 2x is exponential term. So x will be your u and e raised to 2x will be your v. So we are ready to apply the formula. Your x will be as it is. We have to integrate e raised to 2x, which is e raised to 2x upon 2 minus integration of product of differentiation of u, which will be 1, and integration of v, which will be e raised to 2x by 2. So now your first term will be as it is, and in second term we can take 1 by 2 outside. So integration of e raised to 2x will be e raised to 2x by 2 plus c. Now for simplification, we can take e raised to 2x common. So we will get x by 2 minus 1 by 4 plus c. Or we can say e raised to 2x. After taking LCM, we will get 2x minus 1 by 4 plus c. But we already have the integration. So let's compare them. We can say your fx must be 2x minus 1 by 4, which is given in option C. Ta-da! Here we have to integrate x cube into log x. Your x cube is algebraic term and log x is logarithmic term. So x cube will be v and log x will be u. So we are ready to apply the integration by parts. Your log x will be as it is. We have to integrate your v, which is x cube. So its integration will be x raised to 4 by 4 minus integration of product of differentiation of u, which is log x. Or we can say it will be 1 by x and integration of v, which is x cube. So its integration will be x raised to 4 by 4. So now your first term will be as it is minus in second term 1 power of x will reduce and this 1 by 4 is constant, take it outside. So we just have to integrate x cube. So first term as it is and integration of x raised to 3 will be x raised to 4 by 4 plus c. If we take LCM, we will get 4x raised to 4 log x minus x raised to 4 whole divided by 16 plus c, which is given in option B. Ta-da! Here we have to integrate log of log x plus 1 upon log x the whole square. Here your inner function is log x. So let's assume log x is equal to t. Now we don't have any differentiation of log x. So let's make x objective. So we get e raised to t. So your dx will become e raised to t dot dt. So let's modify our integration. We will get log t plus 1 upon t square into e raised to t dot dt. Now, this e raised to t within the multiplication of dt suggests that we have to use this formula. And for that, we need to set the differentiation of log t, which is actually 1 by t. So let's add and remove 1 by t, and your 1 by t square will be as it is. Now, let's multiply e raised to t with first two terms. So here we'll get log t plus 1 by t into e raised to t dot dt. And from rest of the two terms, if we take minus common, then we will get 1 by t plus minus 1 upon t square into e raised to t dot dt. So here, as you can see, we have f of t plus its differentiation. And again, in second term, also we have f of t and its differentiation. So to integrate these terms, we just have to neglect the term of f dash. So your answer will be log t into e raised to t minus 1 by t into e raised to t plus c. For simplification, let's take e raised to t common. We will get log t minus 1 by t plus c. And to get the final answer, we just have to substitute the value of t. Your e raised to t is simply x. Your log t will be log of log x minus 1 by log x. And if you multiply x with two terms, we will get x into log of log x and x upon log x plus c, which is given in option B. Ta-da! Here we have integration of log x square plus x is equal to x log x square plus x plus a, and we have to find the value of a. So first of all, let's begin from the left hand side. We have log of x square plus x, or if we take x common, we will get x into x plus 1. Now here we have log a into b, so we can split as log a plus integration of log b. And we know that to integrate logarithmic term, we have to assume log x into 1. We will select log x as u and 1 as v. So it will be log x into integration of 1, which will be x, minus integration of product of differentiation of u, which is 1 by x, and integration of 1, which will be x. Similarly, in second term, we will have log x plus 1 into 1. Log x plus 1 will be selected as u and 1 will be your v. So in first term, your log x plus 1 will be as it is. We have to integrate your v, which is 1. So it will be x minus integration of product of differentiation of u, which is log x plus 1. And its differentiation will be 1 upon x plus 1 into integration of 1, which will be x dot dx. From first and third term, let's take x common. So we will get log x plus log of x plus 1. Now your xx will cancel out and integration of 1 will be x, and in last term actually we have x upon x plus 1. So to get plus 1, let's add and remove 1 and give individual denominator. So x plus 1 will cancel out and we just have to integrate 1, which will be x, minus minus plus integration of 1 upon x plus 1 will be log x plus 1 plus c. So here your x will be as it is. We have log a plus log b. So we will get log of a into b, or we can say log of x square plus x minus 2x plus log of x plus 1 plus constant. So we complete our integration. Now let's compare with the given right hand side. So we can say your a is minus 2x plus log x plus 1 plus c, which is not given in a, b or c. So option D will be selected as correct answer. Ta-da! antiderivative of f of x is e raised to x. That means integration of f of x is e raised to x. So we can say your fx is simply e raised to x. And similarly, antiderivative of g of x is cos x. So we can say your g of x is differentiation of cos x. Or we can say minus sin x. Then we have to find out integration of f of x cos x and g of x e raised to x. Now just substitute the value of f of x and g of x. We will get e raised to x cos x plus minus sin x e raised to x. We can take e raised to x common. So we will get cos x plus minus sin x. So here we set e raised to x fx plus f dash x. And we know that to integrate this kind of a form, we just have to ignore f dash x. So your answer will be e raised to x fx. In this case, it is cos x plus c, which is given in option C. Ta-da! In this question, we have to find integration of log x upon x plus 1 the whole square. Or we can say we have log x into x plus 1 raised to minus 2. Your log x is a logarithmic term and x plus 1 raised to minus 2 is algebraic term. So log x will be selected as u and x plus 1 raised to minus 2 will select as v. So let's apply integration by parts. In first term, your u, or we can say log x, will be as it is. We have to integrate v, which will be x plus 1 raised to minus 1 upon minus 1 minus integration of differentiation of your u, which will be 1 by x, and integration of v, which will be x plus 1 raised to minus 1 upon minus 1. So we will get minus log x upon x plus 1. Then this minus minus become plus, and we will have 1 upon x into x plus 1. Now to integrate second term, let's add and remove x, and your first term will be as it is and give individual denominator. So we will get x plus 1 upon x into x plus 1 minus x upon x into x plus 1 dot dx. Now your first term will be as it is, and here x plus 1 will cancel out. Integration of 1 upon x will be log x minus xx will cancel out. Its integration will be log x plus 1 plus c, which is given in option A. Ta-da! Here we have to integrate e raised to x into 1 minus x upon 1 plus x square the whole square. Or we can say, let's expand in numerator. So we will get 1 minus 2x plus x square. And in denominator, we will have 1 plus x square the whole square. Okay, now let's give individual denominator. In first term, we will take 1 plus x square. 1 plus x square the whole square. And then we will take minus 2x upon 1 plus x square the whole square dot dx. Now here we can cancel out 1 power of 1 plus x square. So we will get 1 upon 1 plus x square plus minus 2x upon 1 plus x square the whole square. And if we select 1 upon 1 plus x square as fx, we will get its differentiation in second term. So to integrate this term, you just have to neglect f dash x, and your final answer will be e raised to x into 1 upon 1 plus x square plus c, which is given in option C. Ta-da! Here we have to integrate inverse trigonometry, and we know that to integrate inverse trigonometry, we simply have to assume tan inverse root x is equal to t, where t is belongs to 0 to pi by 2. So if we make x subjective, we will get tan t the whole square. Differentiate both the side, we will get dx is equal to 2 into tan t into differentiation of tan t, which is sec square t dot dt. So we are ready to integrate. This tan inverse root x will become your t, and this dx will become 2 times tan t into sec square t dot dt. Okay, now this 2 is constant, take it outside, and we have to apply integration by parts, where t will be selected as u and tan t into sec square t whole will be selected as v. So let's apply the formula. In first term, your u will be as it is. We have to integrate tan t into sec square t, which is actually f of t into f dash t. So its integration will be f dash t the whole square by 2, or we can say tan t the whole square by 2 minus integration of differentiation of u, which is t, so it will be 1, and integration of v, which is again tan t into sec square t, so it will be tan square t by 2 dot dt. Now let's multiply 2 within the bracket, so we will get t into tan t the whole square minus, we just have to integrate tan square t, which can be converted into sec square t minus 1. So here we'll get t tan square t minus integration of sec square t will be tan t, and integration of 1 will be t plus c. And to get the final answer, just substitute the value of t. Your t is simply tan inverse root x. Your tan square t is nothing but x, minus tan t is root x, and your t is tan inverse of root x plus c. So if we take tan inverse root x common from first and last term, we will get x plus 1 minus root x plus c will be your final answer, which is given in option A. Ta-da!